The night sky over the city is a canvas of inky black, punctuated only by the distant glow of city lights and the cold pinpricks of stars. Suddenly, a new light appears. It is not a star, it is a streak of malevolent fire, an enemy missile arcing silently through the upper atmosphere, descending at unimaginable speed. On the ground, people sleep, unaware of the death that hurtles towards them from miles above. This single weapon carries enough destructive power to turn a city block into a crater, to shatter lives in an instant. It is a terrifying testament to the destructive power of modern warfare, a silent messenger of chaos racing towards its target with unstoppable momentum. But it is not unanswered. From the darkened fields on the city's edge, a response erupts. A column of brilliant white fire tears into the night, a guardian launched to meet the threat head-on. This is an interceptor missile, a product of decades of engineering and a nation's desperate need for protection. It climbs with astonishing velocity, its rocket motor burning with a ferocity that briefly turns night into day. It is a sliver of hope against the descending darkness, a technological shield rising to defend the defenseless. The people below may not see it, may not hear it, but their very survival now depends on this single, violent ballet playing out in the heavens. The two lights converge in a brilliant, silent flash. For a heartbeat, a new, blinding star is born in the sky, a star of annihilation where attacker and defender meet. The explosion is a testament to incredible precision, a collision orchestrated by powerful radars and sophisticated computers calculating trajectories in microseconds. The enemy warhead is shattered into a million harmless pieces, burning out harmlessly as they fall through the atmosphere like a shower of fleeting meteors. The threat is neutralized. The city below remains untouched, its inhabitants still lost in their dreams, completely oblivious to the cataclysm that was averted just moments before by these silent sentinels. This dramatic, high-stakes duel is happening right now in conflicts around the world. It is the front line of a new kind of warfare, one fought not with trenches and tanks, but with algorithms and rockets. This is the battle of air defense, a constant, nerve-wracking struggle between the sword and the shield. It is a contest of speed, intelligence, and technology, where a fractional delay can mean the difference between a successful interception and a national catastrophe. The silent sentinels, the air defense systems, are the new fortress walls of the 21st century, the last line of defense against an ever-growing arsenal of aerial threats. In our modern world, the sky is no longer just a space for travel and weather. It has become a highway for destruction. Nations now possess a terrifying array of weapons that can be launched from hundreds, even thousands of miles away. These are not just the ballistic missiles of the Cold War era. Today, the threats include highly maneuverable cruise missiles that hug the terrain to avoid detection, swarms of inexpensive drones that can overwhelm defenses through sheer numbers, and precision-guided rockets. This proliferation of aerial weapons means that no city, no military base, and no civilian population center is truly safe. The threat can emerge from any direction, at any time, making a robust defense an absolute necessity. The primary role of air defense is, quite simply, to create a protective bubble. This bubble, or no-fly zone, is designed to shield critical assets. These assets can be strategic, such as government buildings, power plants, and industrial centers that are vital for a nation to function. They can be military, like airfields where fighter jets are based, naval ports housing a nation's fleet, or command posts from which a war is directed. And most importantly, they can be civilian. Air defense systems are the guardians standing watch over homes, schools, and hospitals, ensuring that the daily lives of ordinary people can continue without the constant fear of attack from above. Without effective air defense, a country is profoundly vulnerable. An adversary could cripple a nation's military capabilities before a single soldier ever crosses a border, simply by destroying its airfields and command structures from a distance. They could sow terror and chaos among the civilian population, breaking the national will to fight. In this sense, air defense is not just a defensive tool. It is a strategic enabler. It allows a nation's own air force to operate safely, its ground troops to maneuver without fear of constant aerial bombardment, and its government to make decisions from a position of security, not panic. It preserves a nation's freedom of action. Ultimately, the importance of air defense extends beyond the battlefield. The mere possession of a credible air defense system is a powerful deterrent. It sends a clear message to potential aggressors. An attack on us will be costly and may very well fail. This changes the strategic calculation, making a potential conflict less appealing. In a world where tensions can escalate quickly, these unseen shields are a crucial element of national sovereignty and stability. They are the high-tech guardians that allow a nation to control its own skies, and in doing so, to control its own destiny in an increasingly dangerous world. The process of stopping a missile mid-flight is a symphony of technology, executed in seconds. It all begins with detection. The eyes of any modern air defense system are its powerful radars. These are not simple spinning dishes. They are often sophisticated phased array radars. Instead of physically moving, these radars steer their beams electronically, allowing them to scan vast swaths of the sky almost instantaneously and track hundreds of potential targets at once. A radar sends out pulses of radio energy. When these pulses hit an object like an incoming missile, they bounce back. The system's computers analyze these returning echoes to determine the object's location, speed, altitude, and trajectory. Once a potential threat is detected, the second stage, tracking, begins. This is not a one-time event. The system must continuously follow the object, updating its position 1,000 times a second. The computers analyze the flight path to determine if it is a genuine threat. Is it a civilian airliner on a scheduled flight path? Or is it a small, fast-moving object heading directly for a sensitive military installation? Sophisticated algorithms filter out the noise, birds, weather phenomena, and friendly aircraft to lock onto the hostile target. This continuous, high-fidelity tracking is crucial for calculating the precise point in the sky where the interception must occur. With the target identified and its flight path calculated, the command is given to engage. This is the destroy phase. An interceptor missile is launched from its canister with a thunderous roar. For the first part of its journey, it is guided by the ground-based radar, which acts like a controller telling the missile where to go. This is known as command guidance. The ground radar tracks both the incoming threat and the outgoing interceptor, constantly sending course corrections to the interceptor to put it on a perfect collision course. This ensures the interceptor missile conserves its own energy for the most critical final moments of the engagement. In the final heart-stopping seconds, many advanced interceptors switch to their own onboard radar seeker. This is the terminal phase. The interceptor missile is now autonomous, using its own small radar to lock onto the target with pinpoint accuracy. This active homing allows for incredible precision, enabling the interceptor to adjust for any last-second maneuvers the enemy missile might make. The goal is often not just to get close, but to achieve a direct hit, a kinetic kill. The sheer force of the collision, at combined speeds of several miles per second, is enough to vaporize the target, ensuring its warhead is destroyed far from its intended destination. The MM-104 Patriot is one of the most famous and battle-proven air defense systems in the world. Its story begins during the Cold War, when it was designed to protect NATO forces in Europe from the threat of Soviet aircraft and tactical ballistic missiles. First deployed in the early 1980s, the Patriot was a revolutionary system for its time, combining advanced radar technology and a powerful interceptor into a single mobile package. Its name, an acronym for Phased Array Tracking Radar to Intercept on Target, perfectly describes its core function. It was built to be a workhorse, a reliable defender that could be moved to wherever it was needed most, a mission it has fulfilled for over 4 decades. The Patriot system is not a single vehicle, but a battery, a team of components working together. At its heart is the AN/MPQ-65 radar, a powerful phased array system that can scan a wide sector of the sky, tracking over 100 potential targets and guiding up to 9 missiles simultaneously. This radar feeds information to the engagement control station, the brain of the operation, where human operators oversee the battle. When a threat is engaged, the command is sent to the M901 launching stations, which carry the interceptor missiles. These missiles have been continuously upgraded over the years, from the original PAC-1 to the modern PAC-3 MSE, which is smaller, more agile, and designed for direct kinetic kills. The Patriot's first major test came during the 1991 Gulf War, where it was deployed to defend coalition forces and Israeli cities against Iraqi Scud missiles. Its performance was a subject of intense debate, but it marked the first time an anti-missile system had been used in combat. The lessons learned spurred decades of improvements. By the 2003 invasion of Iraq, a vastly improved Patriot system demonstrated its capabilities by successfully intercepting multiple Iraqi missiles. More recently, it has been a crucial component of the defense of Saudi Arabia against Houthi missile and drone attacks, and has been supplied to Ukraine, where it has reportedly intercepted advanced Russian missiles, including hypersonic ones. Despite its age, the Patriot remains a formidable and highly sought-after system due to its constant evolution. The latest PAC-3 MSE, or Missile Segment Enhancement interceptors, are a world away from the originals. They are faster, have a longer range, and are equipped with advanced seekers for incredible accuracy. The system's software and radar are also continually updated to deal with new and emerging threats, from stealthy cruise missiles to complex drone swarms. The Patriot's long combat history provides it with an invaluable library of real-world data, making it one of the most reliable and trusted air defense systems on the planet. The S-400 Triumph, known to NATO as the SA-21 Growler, is Russia's premier long-range air defense system and is widely regarded as one of the most capable in the world. It's the successor to the already formidable S-300 family, designed not just as an upgrade, but as a generational leap in capability. Developed in the 1990s and introduced in 2007, the S-400 was conceived to be a comprehensive solution to air defense, capable of engaging a vast spectrum of aerial threats. Its primary design philosophy is layered defense. It doesn't rely on a single type of missile, but can employ a variety of different interceptors to handle different threats at different ranges and altitudes, creating a near-impenetrable fortress of overlapping defensive zones. What makes the S-400 so feared is its incredible flexibility and range. The system can launch at least 4 different types of missiles. For very long-range targets, like enemy command and control aircraft or bombers, it can use the 40N6E missile, which has a staggering claimed range of up to 400 kilometers, or about 250 miles. For closer, faster targets like fighter jets or cruise missiles, it can use smaller, more agile missiles like the 9M96E2. This multi-layered approach allows a single S-400 battery to defend a huge area, engaging everything from high-altitude strategic bombers to low-flying drones skimming the treetops, making it an incredibly efficient and dangerous weapon. The system's advanced radar suite is another key to its effectiveness. The S-400 uses a combination of radars, including a large survey radar to detect targets at long distances, and multiple engagement radars to guide missiles. This network of sensors gives it excellent situational awareness and makes it highly resistant to electronic jamming. The system is designed to be highly mobile, with all components mounted on trucks, allowing it to be rapidly deployed, set up, and moved to a new location to avoid counterattacks. This shoot-and-scoot capability is a core tenet of modern Russian military doctrine, enhancing the system's survivability on a contested battlefield. The S-400's strategic impact has been significant. Russia has deployed it to protect its most critical assets at home and its expeditionary forces, such as those in Syria, creating a powerful anti-access and area denial bubble that complicates the air operations of any potential adversary. Its sale to other nations, including NATO member Turkey, China, and India, has caused major geopolitical shifts and diplomatic tensions. For these countries, acquiring the S-400 is a statement of strategic autonomy and a major upgrade to their defensive capabilities, reflecting the system's status as a top-tier asset in the global arms market. While the Patriot and S-400 often dominate headlines, the world of air defense is populated by a diverse range of highly effective systems, each designed for a specific role. One of the most prominent is the Norwegian-American NASAMS, or National Advanced Surface-to-Air Missile System. What makes NASAMS so clever is its innovative use of the AIM-120 AMRAAM missile, the same weapon used by most Western fighter jets. This shared ammunition really simplifies logistics and reduces costs. NASAMS is a medium-range system designed to protect high-value targets like cities and air bases. Its distributed and networked architecture means its components can be spread out over a large area, making it harder to target and destroy. It has gained recent fame for its highly effective use in Ukraine. At the shorter range end of the spectrum is Israel's famous Iron Dome. This system was born out of a very specific and urgent need to protect Israeli communities from the constant threat of short-range rockets and mortar shells fired from just a few miles away. Iron Dome is a masterpiece of specialized engineering. Its radar can detect and track dozens of incoming projectiles simultaneously, calculate their trajectories, and determine which ones pose a threat to populated areas. It then fires a nimble Tamir interceptor to destroy only the rockets that are a danger, ignoring those that will land in open fields. This cost-effective approach has allowed it to achieve thousands of successful interceptions, saving countless lives. For threats that are higher and faster, the United States employs the Terminal High Altitude Area Defense, or THAAD system. As its name suggests, THAAD is designed to intercept ballistic missiles in their terminal phase as they plummet back towards Earth from the upper atmosphere. It operates on a simple but devastating principle: hit to kill. The THAAD interceptor carries no explosive warhead. Instead, it uses sheer kinetic energy, slamming into the incoming missile at hypersonic speeds to obliterate it. THAAD provides a crucial upper-tier layer of defense, sitting above systems like Patriot, and has been deployed in key locations like South Korea and Guam to counter threats from North Korean ballistic missiles. Not to be outdone, China has developed its own sophisticated long-range system, the HQ-9. Heavily influenced by the Russian S-300 and American Patriot, the HQ-9 is a formidable competitor that reflects China's growing technological prowess. It is a highly mobile system with advanced phased-array radar and a family of missiles capable of engaging targets at long ranges and high altitudes. China has deployed the HQ-9 extensively to protect its own territory and has also become a major exporter of the system, offering a credible alternative to Russian and Western designs. Together, these systems show that air defense is a global endeavor, with each nation tailoring its technology to meet its unique security challenges. When comparing the American Patriot and the Russian S-400, it's like comparing a seasoned, battle-hardened warrior with a highly versatile, multi-talented athlete. The Patriot's greatest strength is its long and proven combat record. It has been tested in fire for decades, and each conflict has led to crucial upgrades. Its latest interceptor, the PAC-3 MSE, is a marvel of precision, designed specifically for the hit-to-kill mission against fast-moving ballistic missiles. Its radar is optimized for this role, providing incredibly accurate tracking data. However, its maximum engagement range is generally considered to be shorter than the S-400s, with the PAC-3 MSE effective out to around 160 kilometers, focusing its excellence within a more concentrated defensive bubble. The S-400, on the other hand, is defined by its staggering range and layered defense philosophy. Its ability to use the 40 N-6E missile gives it a theoretical reach of 400 kilometers, allowing it to threaten high-value assets like AWACS command planes and aerial tankers deep behind enemy lines. This is a capability the Patriot system does not possess. Furthermore, by being able to mix and match different missiles in its launchers, a single S-400 battery can simultaneously threaten targets at long, medium, and short ranges. This versatility makes it an exceptionally dangerous system for any Air Force to face, creating a vast area of denial that is difficult to penetrate. In terms of their radar and sensor suites, both systems are incredibly advanced but reflect different design philosophies. The Patriot's single AN/MPQ-65 radar is extremely powerful and optimized for engaging a specific sector with high precision. It is designed to work as part of a wider network of American and NATO sensors. The S-400, in contrast, typically deploys with its own suite of radars, a large surveillance radar for early warning and smaller engagement radars for guiding missiles. This can make a single S-400 battery more autonomous, but also potentially a larger and more complex target for an enemy to find and destroy. Success rates are notoriously difficult to verify and are often subject to wartime propaganda. The Patriot has a publicly documented list of successes, particularly with its newer PAC-3 variants in the Middle East and Ukraine, where they have proven highly effective against advanced ballistic and cruise missiles. The S-400 has seen less large-scale combat use against peer adversaries, so its claimed capabilities are less independently verified. Ultimately, the better system depends on the mission. For dedicated point defense against the most advanced ballistic missiles, the battle-tested Patriot PAC-3 is a world-class solution. For creating a vast, multi-layered defensive zone that can threaten a wide variety of targets, the S-400's range and flexibility give it a powerful edge. The battlefield is the ultimate and most unforgiving test for any air defense system. In recent years, we have seen numerous examples of these systems performing brilliantly under pressure. In Ukraine, The arrival of Western systems like the Patriot and NASAMS has been a game-changer. They have been credited with intercepting some of Russia's most advanced weapons, including the Kinzhal hypersonic missile, which was previously thought to be unstoppable. These successes have not only saved lives and protected critical infrastructure, but have also shattered the myth of Russian missile invincibility, demonstrating the remarkable capabilities of modern Western interceptor technology when put to the test in a high-intensity conflict. Similarly, Israel's Iron Dome has an unparalleled record of success, but within its specific niche. It has performed thousands of interceptions against short-range rockets, achieving a success rate often cited as over 90%. This has fundamentally changed life for citizens in southern Israel, allowing a semblance of normality to continue under the threat of constant bombardment. In the Middle East, Patriot batteries operated by Saudi Arabia and the UAE have been engaged in a long-running, low-intensity conflict against drones and missiles launched by Houthi rebels in Yemen. These engagements have provided invaluable real-world data, highlighting the growing threat from cheap, mass-produced drones and the need for cost-effective ways to counter them. However, air defense systems are not infallible, and the battlefield has also exposed their limitations. One of the greatest challenges is saturation. An attacker can launch a massive wave of missiles and drones, far more than the defending system can possibly engage at once. The system's radar can only track so many targets, and its launchers only hold a limited number of interceptors. Once those interceptors are expended, the battery is vulnerable until it can be reloaded, a process that takes time. This tactic of overwhelming the defender is a common strategy, forcing the defense to make impossible choices about which incoming threats to prioritize. Another major challenge is the rise of new technologies designed specifically to defeat air defense. Stealth aircraft and missiles are coated with radar-absorbent materials and shaped to deflect radar waves, making them incredibly difficult to detect until it is too late. Hypersonic weapons, which travel at more than 5 times the speed of sound and can maneuver unpredictably, push detection and interception timelines to their absolute limits. Furthermore, electronic warfare can be used to jam or deceive a system's radar, blinding it at the critical moment. These brutal realities show that air defense is a relentless cat-and-mouse game, where every success is temporary and every vulnerability will eventually be exploited. The sky battle is far from over. In fact, it's entering a new and more complex era. The limitations of current missile-based systems are becoming clearer. First and foremost is the issue of cost. A single interceptor missile, like a Patriot PAC-3, can cost several $1,000,000. Firing one of these to shoot down a drone that costs only a few $1,000s is an unsustainable economic proposition. This cost curve problem is a major driver of innovation, pushing nations to develop cheaper ways to defeat low-cost threats. The future of air defense cannot rely solely on expensive interceptors, especially when faced with the threat of massive drone swarms. To solve this, militaries around the world are racing to develop directed energy weapons. The most promising of these are high-energy lasers. A laser weapon offers the potential for a nearly unlimited number of shots, limited only by its power supply. The cost per shot would be negligible, a few dollars worth of electricity, compared to millions for a missile. These systems could be perfect for dealing with swarms of drones or incoming rockets, while still facing challenges with weather like fog and rain, which can dissipate the beam. Prototype laser systems are already being tested and mounted on naval ships and army trucks, heralding a major shift in defensive technology. Alongside lasers, high-power microwaves offer another path forward. These weapons don't destroy a target with heat, but instead emit a powerful beam of microwave energy that overloads and fries the sensitive electronics inside a drone or missile. An entire swarm of drones could potentially be disabled with a single blast. Furthermore, the world of electronic warfare is becoming ever more sophisticated. Future air defense networks will use advanced AI to detect and counter enemy jamming, and will themselves become powerful electronic weapons, able to disrupt the guidance systems of incoming threats without ever firing a shot, turning an enemy's own technology against them. The ultimate future of air defense lies in a networked, multi-layered approach that combines the best of the old and the new. Kinetic interceptors like the Patriot and THAAD will still be needed to defeat high-end threats like hypersonic missiles and re-entry vehicles, but they will be integrated into a wider grid that includes lasers for short-range defense, high-power microwaves for countering swarms, and sophisticated electronic warfare systems. This integrated shield, powered by artificial intelligence to manage the immense complexity of the modern battlespace, represents the next frontline. The race to control the skies is a race of innovation, and the nation that masters this new technological frontier will hold the ultimate high ground.